Good morning, you guys. So first and foremost, we should have our homework out. If you have not gotten that out, I am going to go through the answers very quickly from the homework that you guys had to finish over the weekend. So please get that homework out right now. I'll give you about a few seconds before I start walking through the answers for 10 through 15. And you need that packet out anyway, as that's what we're going to take some notes on. So I'll give you guys another moment. Okay, so with question number 10, this is one of the questions we did very similar on Friday. We're going to focus in on the fact that that side of the triangle and this mid segment are parallel. We're going to look at parallel lines cut by a transversal. That's going to be really important for us to look at. And if I just kind of zoom in on that half of the picture, we can see that question or angle 56 and angle 2. Those are corresponding angles. So we know that corresponding angles are congruent. So angle 2 is 56 degrees. We can also see that 56 and angle 3 are a linear pair. If we just, I'm going to really zoom in on that part of the picture. So 56 and 3 are a linear pair. Linear pairs add up to 180 degrees. So I'm going to take 180 and I'm going to subtract 56. That will leave me with 124 degrees for angle 3. So I'm going to add that in there. Now, popping over to the other side of this, we can see that these two angles right there, 144 and angle 5, those are also a linear pair. So I'm going to take 180, I'm going to subtract 144. That leaves me with 36 degrees for angle 5. And if I zoom in and I kind of eliminate that part of the picture, I see I have a triangle, and we know that all angles in a triangle add up to 180 degrees. So I'm going to take 180, I'm going to subtract out that 36, and I'm going to subtract out 56. And once I do all of that, I get 88 degrees for angle 4. So again, all three angles of every triangle add up to 180 degrees. So I'm going to put that in there. This one is 88 degrees. Now, angle 1, let's pop over and let's look at a different transversal. We still have that mid segment and that side being parallel, but now if I look at this side as a transversal, I can see that I have 36 or angle 5 and angle 1 we would consider to be corresponding. And corresponding angles are congruent. So we know that angle 1 should also be 36 degrees. So those are the answers to question number 10. If we take a look at question number 11, question 11 is done very similar to that. I have parallel lines. There's my side of the triangle, and there's the mid segment of the triangle. And I have a transversal put in there, excuse me. And if this angle is 35, that angle 1, is also 35 degrees. I have a linear pair between angle 1 and angle 2, so 180 minus 35 gives me 145. I see that angle 1, I'm going to put that in there, is 35. And again, we've got that little triangle right there with that 90 degree in that corner. So angle 1, the 90 degree, and angle 5, that is a triangle. And all three angles of a triangle add up to 180 degrees. So if I take 180, I subtract 35, I subtract 90, that leaves me with 55 degrees for angle 5. And I'm going to change the transversal. I'm going to change the transversal to be over here. The first thing I'm going to take care of is that linear pair. So 180 minus 55, that leaves me with 125 for angle 4. And I have corresponding angles between 5 and 3. So 3 is 55 degrees also. As I look through the next answers, I'm going to emphasize the parallel lines, but these just require one bit of work for us. We've got my parallel lines, we have my transversal, and I see that these angles would be considered corresponding, therefore they are equal. 6x plus 1 is equal to 9x minus 23. Subtract the 6x on both sides. Add 23 on both sides, divide by 3, x equals 8 for number 12. Number 13, again, parallel lines, cut by a transversal. I've been doing the parallel lines in yellow, I'm sorry, I don't want to switch that up on you guys. Parallel lines, there's my transversal. But if I take a look at those two angles, those are not corresponding, but one is obtuse and the other is acute, and they are between the parallel lines. These would be considered your same side interior. They are not congruent, but they are supplementary, which means I add them together and set them equal to 180. They're not congruent. They're not equal, they are supplementary. Same side interior are supplementary. So I'm going to combine like terms. This would be 13x. There's a negative 24 and a positive 9, which would be negative 15 equals 180. Add 15 to both sides and divide by 13. And I get out that x is 15. Last but not least, I'm going to zoom out a little bit just for those of you who are with me much faster. Those are, if I'm looking at this angle and this angle, they are going to be considered same side interior again. So that means that I have 16x minus 3 plus 3x minus 7 equals 180. Combine like terms. Add 10, divide by 19, and x would come out as 10. Looking at this question, I want to make sure that I'm answering the question. The question says A, C, B. So I'm actually looking for this angle right down there. So if you solve for x, you're close. That's going to be really important for us, but you're not totally there yet. Make sure you're answering the actual question. Looking at this picture, I see this angle and this angle. Those are corresponding, so those are going to be equal. I have 5x minus 2 equals 13. 5x equals 15, and x comes out to be 3. So if you got x equals 3, that's fantastic. What I need to do, though, is I need to substitute x back in. So I have 6 times 3, which is 18. 18 plus 13 gives me this angle right here is 31 degrees. And why I emphasize that angle is I know that up there is 62. This is what I'm finding, and this one is now 31. If I looked at the big blue picture, that's a triangle right there. And I know that all 3 angles of every triangle add up to 180 degrees. So I'm going to take 180, I'm going to subtract 31, and I'm also going to subtract 62. That leaves me with 87 as my answer for that question. All right, so that was your homework. That was what you guys were supposed to work on over the weekend. So I want you to flip the page. We're going to start looking at perpendicular bisectors. Perpendicular bisectors. So you guys know that perpendicular means it creates a 90-degree angle. Bisect means it cuts the side in half. Cuts in half. So not only are we going to create a 90-degree angle, so here's the creates a 90. We're going to see that right there, that you're going to have a segment or a line or a ray or something. And in this picture, we're actually looking at that thing, CD. In this case, it would be a line. So it said line CD is perpendicular to segment AB. So not only did I tell you it was perpendicular, but I also told you the bisect part. It cut it in half. And what it said is segment AD was congruent to DB. So notice we have those written in there. So here's what it says. It says if a point lies on the perpendicular bisector. So the point that we're going to talk about, if a point lies on the perpendicular bisector, we're going to look at point C right here. Then it is equidistant. There's a new word for you guys, equa. We've seen that in equilateral or equiangular. That means equal. So it says equidistant. That means equal distance from the endpoints of the segment. Guys, that means that segment CA, this guy over here, CA, that distance from C to A is equal distance to as segment CB, or is equal distance from C to B. That's the same length. And ladies and gentlemen, I'm going to go back a little bit. Even if we didn't have this theorem, even if we didn't, we know that we learned I could add in the reflexive in there. And we know that this triangle over here on the left would be congruent to this triangle over here on the right because of our, if we take a look, here's my side, here's an angle, and here's this other reflexive side. We know those triangles are congruent. So therefore, their parts are also going to be congruent. Their hypotenuses are going to be congruent because they're the same triangle. So that's bringing back some old stuff. But here's our theorem. If a point C, lies on the perpendicular bisector, then it is equal distant to the points on the end points. I'm sorry. Equal distant from the end points on the segment. Those are the words that I'm trying to get out tonight. So we've got CB. And it goes the other direction. If I tell you that the hypotenuse is congruent, then you know it's a perpendicular bisector. So if I tell you the hypotenuses are congruent, and so if AC is congruent to CB and it has to be perpendicular, and CD is perpendicular to AB, then we know that it has also cut it in half, that AD is congruent to DB. So let's take a look. Let's put it in action. Here's what we know. We know that we have a segment that was cut in half because they told us that those markings mean the same. We also have a 90-degree. And when you see that you have it perpendicular and a split in half side, you know that this side right here, 7x minus 24, is going to be equal to this other side. The hypotenuses are going to be equal. So we would take 7x plus 24 and set that equal to 13x minus 48. Subtract 7x on both sides. And I get out 6x minus 48 equals 24. Add 48 on both sides. So 24 plus 48. And you get out 72. Divide both sides by 6. And you get out 12. Number 2, here's what I see. I see the hypotenuses are congruent, and I also see the 90 degree. If the hypotenuses are congruent and I have that perpendicular, that means those sides are also congruent. So I'm going to set 17x minus 3 equal to 9x plus 13. So I take 17, subtracting that 9x on both sides, I get 8x minus 3 equals 13, add 3, and I get out that x is 2. Down here, if I see that I have sides that are congruent and I see the 90 degree, then I know that the hypotenuses have to be congruent. So 7x minus 22 equals 4x plus 5. Subtract the 4x on both sides, add the 22, divide by 3. But I'm not done. This time they wanted me to actually find that length of RS. So it is important for me to solve that x is 9, but I do need to make sure that I'm actually answering that question. So substitute that back in. 4 times 9 is 36. And go ahead after that, add 5. We get out that my final answer is 41. And number 4, we're going to find EG. I see that my hypotenuses are the same. I see that I have that 90 degree. That means these sides must be the same also. So I'm going to set those equal. 2x plus 1, 11, equals 14x minus 37. Subtract that 2x. Add 37. Divide by 12. And I need to find the length of EG, which means I need to substitute my x answer right back in there for x. 2 times 4 is 8. 8 plus 11 is 19. So EG is 19. Okay, you guys, here's what I want you to do for homework. We will look at some other examples later. Turn your page, skip the angle bisectors. We'll do that when I get back. Your homework, what I want you guys to work on is going to be 1 through 7. Now, number 7 is going to be a bit hard. So if you aren't able to do that, just number 7, if you can only get parts of that, I understand. But here's my hints to you, okay? Here's my hints. I am hinting to you that side PQ is equal to QR. I'm also going to give you the hint that, let's see, we want to find, do they want you to find? Yep. PS, we can see it because they marked it, is equal to SR. Your pink stuff will help you find Y. Your blue stuff will help you find X. And I want you to do this one last. I want you to do PT last. You're going to need to solve for both X and Y before you can solve for PT. You guys should be able to do that, but it will take you a little bit of work. But questions 1 through 7, you guys have the rest of the time here in class in order for you to probably get your homework done. So no excuses tomorrow when I check it in. Okay? Have a good day, you guys.